Hello and welcome back to another episode of the Parts Bin. This one's going to be freaking cool.
Dude, we have a lot of metal on the table today.
There's like 500 pounds on top of this table. This is a lot of weight. I hope the table doesn't break. We've been working on this stuff for a long time.
Over a year.
Like, I mean, stroker kits, when's the first one you got? It's been a couple years ago.
I think it's been like 4 years ago since I did our first stroker kit.
So we love stroker kits. We love the 6.2 strokers, 6.1 depending on how big your bore size is. But we love that. I mean, you haven't built a non-stroker since you built the stroker.
Every engine I've built since then for my personal use, doesn't matter if it's like a burnout vehicle, stroker.
Yeah, because it's just so much better. Like, there's a huge difference. We've talked to a few people, and we think the stroke is more important than the bore. Like, if you had a bigger bore versus a bigger stroke and you have the same cubic inches, the stroke would be a better running engine. Like, we've experienced that, you've experienced that, and so we are a big fan. So, why do I have all these cranks here? Let me tell you. About 2 years ago, I broke the crank in my Mega Cab Ruby, my 1500 horsepower tow truck, and this is it right here. This is my broken crank. And this was an aftermarket crank, very well known, the Power Stroke Products crank. I've used them before. I've made big power with them, so I had no concerns or anything like that. But I was just staring at my broken crank one day, and I happened to have a true Cummins 6.7 crank, you know, OEM from a factory block sitting next to it. And I was like, man, they just look different. They don't look the same. So I kind of started like measuring and figuring stuff out. And I figured out it is not the same. I'm not here to say that it's wrong. I'm just saying it's not a 6.7 crank. It displaces 6.7 liters when you put it in your engine, but it is not designed the same as a 6.7 liter crank. Do you know, what are the differences, Will, as you've been measuring stuff? You're kind of our measuring scientist guy.
I mean, so I've been measuring the cranks back and forth. A big thing, 6.7s, the counterweights are taller. You know, they're about 100 thousandths taller. They're heavier. A 6.7 crank's about 124 pounds.
Yeah.
5.9 crank's about 121 pounds.
Yeah.
So about 3 pounds of difference. Now, a lot of guys are like, man, great, I get to save 3 pounds on my truck. Awesome.
My crank, yeah, lightweight crank, sweet.
That is not the place to save weight on an engine. In fact, the higher performance they go, they start adding more weight. Top fuel cranks, when they have trouble, they add more counterweight.
Yes.
Any racing application, they've found that more counterweight fixes harmonic issues, braking issues more times than not. The other difference is the meat around the journal. When they design a crank, there's a certain amount of meat depending on the throw. So remember, a 5.9 crank's about a 4.72 stroke. A 6.7 crank is 4.88. So it's about 160 thousandths or 80 thousandths different. You know, the journal goes up and down different. Well, that 80 thousandths means you need more metal on this side. You need to change some of the profile and all that filleting the way that is. And that's factory design that. They spent millions of dollars engineering a 6.7 crank. If they could have just stroked a 5.9 crank, I promise you Cummins would have been like, we've got a shortcut. Let's just offset grind this and do it. That apparently, what it looks like is what a Power Stroke Products 6.7 crank is.
Yeah, I'm not saying what it is. I didn't design it, but when you look at it, it looks, when you start looking at it next to a 5.9 crank and a 6.7 crank, it looks like a 5.9 crank. The counterweights are the same. The design of the actual forging, the forging die marks are like the same. And the 6.7 is different. So knowing this, I decided we got to make a true 6.7 liter crankshaft that's available. Cummins no longer offers this crank. So now you're looking for used cranks in the market. There's a new 10 bolt version, but you know, if you want to build like a stroker motor or if you're a 5.9 Commodore guy and you want to build a 6.7, good idea. Ruby loves it. You know, you can have a crank.
Basically, starting in 2019, Cummins went to a 10 bolt flange on the back of their 6.7 crank. And very quickly, they end of life, they quit making the 8 bolt 6.7 crank.
Yeah.
And guys, there's a lot of trucks built between 2007 and 2018 that have a 6.7 crank. And I got to be honest with you, nobody wants to get undersized bearings. They're not even commonly made in diesels.
No.
It's not like gas performance where there's 14 sizes of undersized main bearings to grind. Like diesel, they're kind of like, oh, there's one undersized and then throw it away. You know?
Yeah. It's just, these are really good. And another thing that I wasn't say I was bugged, but I just didn't think about it until we started going down the road of learning crankshafts. Because when I bought the aftermarket crankshafts, I didn't know the balance. They came in a box. I didn't know the balance. And so every time I bought a crank, I had to go get it balanced. I thought, man, that's kind of weird. Some were great and some needed some work. I mean, I'm not saying 100% one or another, but they need to work. So for all these reasons about the the available aftermarket 6.7 crank in the market, I wanted a true 6.7 design crank. So we went out, and this has been taking, like I said, probably a couple years. We had to get forging dies made. That's a big deal. That takes a long time. Getting the cranks in here. So every one of our cranks, you'll see our logo forged into it. So you know if it has this logo, not cast, forged into it, it's one of our cranks. Also, we have every crank serialized. So that way you can know it's true. The reason I serialize them is because we also want to balance them. So in the past, when I got aftermarket cranks in, I didn't know the balance of the crank. It didn't come with the product. And so I'd take it to the machine shop and get them balanced. Sometimes they could get done quickly. Sometimes it took them a long time depending on their workflows and their workloads. And I wouldn't personally put a crank in an engine that I didn't know the balance of. And so I had to do that. So we got a top of the line crank balancer.
So we got the CWT.
Oh, it's awesome. It's super cool. And so every one of our cranks is going to come with a balance sheet. And like I said, these cranks have a serial number on the front of this counterweight right here that corresponds to the sheet that's going to be in your crank box. So this is PD 4247. So 4247 is the last 4 digits of the serial number on the front of this crank. And you can tell what your balance is. So at first we put it in there, you have an initial spin. The initial spin is what it came from the forging company. So they do a decent job, but we balance these to a much higher level. Every crank is balanced to 5,000 RPM. So if you're under 5,000 RPM, we can handle you. If you want to go over 5,000 RPM, call in. We can balance higher if you need to, but for most guys, 5,000 RPM is plenty. And so you'll see what the balance was before and then what the balance was after. So you'll know the balance of your crank with a serial number with it. So I like that, so you don't have to spend money, waste time.
Now the factory balance on this one, for example, the initial, like, so at 5,000 RPM, this one had, what, 28 pounds of throw-off force? And now it has 17 pounds.
Yeah.
So every time that crank is that few ounces or grams of imbalance at 5,000 RPM, it's almost like a 28-pound hammer going up and down on your main caps. Besides the force the engine has to deal with from making power, that's just from the imbalance. And so the whole point on balance is not to pound on the crank. So one, it doesn't break. And two, it's just a smoother, you know, everyone likes a smooth feeling engine under their feet, you know?
Oh yeah, it's a good running engine. So this is the basis of our stroker kits. It's an actual true to design 6.7 Cummins crankshaft, not a stroked 5.9, but a real 6.7 crankshaft. In the stroker kits, it's very common to upgrade your connecting rods, and we do as well. Now, if you have a 12 valve and you have the factory forged rods, you're not making huge power, you can reuse your factory forged rods. But if you want to make some decent power, you might want to put in some rods. So we offer Waggler rods in our kits. And do you have to do anything to make these fit?
So the Street Fighter rods, they're almost identical size to a factory rod, so they'll drop right in. I've never had clearance issues with a Street Fighter rod. You should always check when you're building the engine. You want to put, mock up 1 or 2 rods, spin it around just to make sure, because, I mean,
different blocks.
These are cast parts. The block, like there's a little, but I found with the billet rods, the main webs are a little fatter down at the bottom. And if you're on a standard bore, like for a 5.9, so 12 valve or 24 valve Cummins, sometimes the billet rod will hit the edge of the cylinder a little bit, and you need to get in there and clearance just the bottom edge of the cylinder. It's a very common thing on stroker, like for gas engines, to like notch cylinders. So we're not talking a full on notch. I'm talking like a Dremel tool or a die grinder and just barely. So if you're running the full billet rods, you need to check closer. I'm pretty sure the rod is going to touch the bore on standard. You get like 40 over, and they both drop in, and they're not even that close. So
nice. So another thing you're gonna need for your stroker kit is pistons. Like I said, or like we were saying, we have to machine 80 thousandths off the top of the pistons. So we kind of have two flavors of pistons here. First off, we're gonna offer the McBee piston. Now, I'm a big fan of McBee pistons, for one, because they're available. All of our piston backorders are always Molle, and we've made big power with McBee pistons, and they've been great. The things that's not as good as a Molle, in my opinion, is the piston rings. I think 450 horsepower and under, the McBee piston rings are great. If I'm going over 450, 500 or above, I want to upgrade my rings. And so then we can offer Total Seal. Total Seal is like the premium ring on the market, and you can get both gapless or your standard gapped rings. You have to set your gap on that, but you can upgrade to this piston ring if you want to, make more than 450, 500 horsepower. Also, we offer the Molle Power Pack pistons. These are awesome from Molle Motorsports. Again, if you're going to go this route, you may be waiting a little bit longer. With this route, we can ship out very quickly. The big holdup is getting pistons in stock so we can machine them for you. And these come with, the Molle rings are great. You can also upgrade the total seal if you want. I say these are the best. I run total seal on pretty much all my engine builds now, but I've had great luck with Molle rings in the past also. Nothing bad to say about those. So power packs are great. This piston's great. We just want to upgrade the rings if you're going over 455 horsepower.
But I mean, they're the top name in rings. So I mean, if you want something to last, that like I've put total seal on power pack pistons too.
Yeah.
And
I've been running total seal in all my race engines for, years, like 10 years. I love the total seal stuff they offer, and they're great.
And if you're a guy that likes your oil to stay clean, that gapless ring option makes the oil stay clean. It drops the blow by a little bit. There's no downside we found to that gapless second ring other than they cost a little bit more. It's probably why factories don't play with them. But yeah, if you want clean oil and you want your engine to purr, opt for those little bit better rings.
I've got the gapless and everything from my tow truck to my race trucks. I've been running gapless for a long time, and I'm a big fan. So for the power-driven diesel 6.7 cranks, you have two varieties here that are on the shelf. This is like your 2003 and newer common rail trucks. It has a straight cut gear on the front. This is for your gear train in the front of your engine. Your 2002 and older trucks have a helical gear, VP44s, your 12 valves, VE trucks. And so make sure you get the right crank for your application. One caveat, there's 2 years of VP44s as a tone ring on the crank itself. We don't have an option for you guys. I'm sorry. I don't have a tone ring crank. So if you have one of those years, just put a 6.7 in it. But anyway, so the stroker cranks for those model years, make sure you get the right crank for your vehicle.
All right, guys, I want to get up close and personal with Cummins crankshafts. First, let's start with an OEM 6.7 crankshaft. What I'm going to do is I'm going to measure from the main journal roughly to the outside edge of the counterweight to get kind of a rough measurement. As you can see here, I'm getting about 2.3 inches. You can see here that there's like no air gap. I've got this right here. Now if we go to an OEM 5.9 Cummins crankshaft, you'll notice this big air gap that we have here. We got a big air gap because the counterweight's shorter. It's actually closer to about 2 inches tall. It's about 2.3, so it's about 300 thousandths shorter. Now if we go to a PowerStroke Products crankshaft, you'll also notice that it too has an air gap. We go back here to the power-driven crankshaft, and it closely matches the 6.7 Cummins crankshaft. You know, and we grind these a little bit when we're doing the balance. So, I mean, this isn't a perfect exact measurement. I'm just trying to tell you in rough magnitude, there's about 300 thousandths of counterweight distance difference between a 6.7 Cummins and a 5.9 Cummins. The other distinct thing you can kind of see with your bare eyes is there are some forging lines left over. So when they make a crankshaft, they make it out of a big chunk of steel, and they hammer these when they're hot, and that's kind of how the forging process works with these big dies. Well, if you look at a 5.9 Cummins crankshaft, there's very distinct forging marks over here on the journal where that has come in, and that looks nearly identical to the PowerStroke Products crank. I'm not hating on this crank. I'm just saying it's modeled after a 5.9 Cummins crank. You look at this forging line here. Then if we go to a 6.7, see the forging line is skinnier and a little bit different angle. And the OEM 6.7, same thing. It's skinnier, a little bit different angle. So you can kind of see some of that. Coming over here further on the front here, we can see this forging line. You can see this area here is quite different. We can see this area here on the PowerStroke Products, very similar to the 5.9. See how the 6.7, the PDD has this kind of skinnier forging line here, a little bit different angle. Same with the OEM crank. You can see these are forged very, very similarly. Getting back further on the counterweights here, we've got some differences in the throws. You see in a 5.9, we go from the journal to the back. There's not much crank beyond the end of the rod journal here. You can see on the PowerStroke Products, it's almost smooth, like I can bounce my finger over here. You go over here to the power-driven crank, and there's little webs hanging up, just like the factory 6.7 crank. So little bit of differences there. When we come around to this side, over here, we start looking, there's actual forging lines. You can see the 5.9 cranks started with a smaller billet of metal when they, the big chunk that they forged out of. These are smaller, and so they had to work the metal more, and the grain structure is steeper. So the angles on the 5.9 are steeper. The 6.7 are a little flatter because they didn't have to forge that rod journal as much. That means the grain structure is a little bit more in line and straight. It's not quite as, bent around, so to speak. So there's very distinct differences in a 5.9 and a 6.7 Cummins crankshaft. And you can see The PDD one very, very closely resembles the OEM Cummins crank that you can no longer buy, and the Power Stroke Products crank very closely resembles a 5.9 Cummins crank.
Also, we have some other new stuff that we're very excited about that goes along with engine parts. So these are stroker kits, but maybe you just want a bigger engine. You want a 6.7 liter. If you're a 24 valve guy, a VP40 guy, or even like you want to do a 24 valve head, P-pump 24 valve, something like that, or you're a 5.9 common rail guy and you do an engine rebuild, why would you do anything but a 6.7 block? So let's walk around the front and talk about this. So this is our new 6.7 liter cast block. This is awesome, and the reason we're in front of Meyer's truck is that's our test bed for this guy. This block right here is in his truck. This crank right here.
There's an elephant in the room we need to address. I lost my stool.
Oh yeah, you're short now.
This is how short I am. Guys, I'm almost 6, well, I'm 5'11", all right? Todd's just a mammoth. Anyway,
moving on.
Moving on. Back to regular scheduled program here.
So we offer like this block as is, and it's a good block. If you want to take a block to your machinist, you're doing something special, this is a great block for you. Order it up, get your machine shop, make sure everything's good. It's a very good starting point, but when we have our stages, we have like 3 stages we're offering above just this block.
But if you just need a 6.7 Cummins block, boom, we've got you covered. These are in stock.
Yep.
But like I said, that's more for sending your machinist if he wants to, you know, dial in everything for you perfect.
And so we offer, like I say, 3 stages above this level. So what's the first one?
So the first stage is kind of like our toe series. What we've done is we've gone in and we've surfaced the block so it's perfectly flat. It's got the right RA finish for your MLS gasket. We've also checked all the bores to make sure we have the right piston and wall clearance so that it's all set up right in factory spec for your piston and wall clearance. We've also checked the main bearing clearance to make sure all of your mains are ready. We've just kind of given it the once over. It's ready for you to take out of the box, wash, and assemble a stock level engine.
Yeah. And after that, we go to our street performance or whatever stage 2 level, which has a fair bit more done to it.
And so the problem we found when you get to that next level is the factory mains on these are 12 millimeters. So the stage 2 or the hot street or street performance, let's say up to, you know, 1200 horsepower guys, we've gone in and we've drilled and tapped the mains on this to 14 millimeter, which gives you that big clamp load for power.
That's what I run on all my stuff, guys. My tow truck at 1500 horsepower, my race truck at north of that, I just run 14 millimeter main studs, and I haven't even bothered. I can't fit a girdle in my race truck, so it's my only option. And it works amazingly well. You get that big fastener with a good quality stud in there, it's a really robust bottom end.
And we're not forcing guys to buy 14 millimeter main studs though. It's drilled and tapped for that, and we include some premium socket cap hardware there that is totally fine. We're actually testing that on the Junker drag truck right now at 1000 horsepower.
It's been great.
It's been just fine. So you don't even need to upgrade the hardware that's there. It's ready for, you know, your stock tow truck all the way up to. But if you're going to that next level, kind of like this engine, then you can just drop your 14 millimeter hardware in there. It has the proper clearance for your big studs on there. We also surface the top, make it that beautiful like 30 RA finish. And then most importantly, when you're getting at that big power level, you need more piston and wall clearance. So we put our torque plate on these. These are torque plate honed on the stage 2 and then we do an extreme plateau hone with our Rottler hone. We open up the piston and wall clearance between 7 and 7.5 thousandths. We give you that good valley depth, that RVK number talk about, and then that CBN finish. And so basically you're getting the best hone job money can buy.
Yeah, it's amazing
on that stage 2.
And
ready to go.
Yeah, so with that, the hone, the surface, mains, that's 1000 horsepower all day block, no problem. You can handle that real easy. And then what we're testing actually in Meyer's truck right now. Meyer's truck, like I said, has one of our stock, well, it has one of our 6.7 liter cranks in it. And then he has 14 millimeter up top. The only difference between stage 3 and stage 4 is 14 millimeter head studs. There's a couple different options for that, right?
Yeah, so the reason we haven't been selling this regularly to guys is on a 24 valve. When you do 14 mil or a 12 valve, it kind of sucks because all of this top end stuff in the head doesn't work. For example, the head stud bores need to be reamed. You can't get the head studs through the head with 14 mil hardware. The rocker box has to be modified.
The bolts are so big, you have to like drill out to make room for the head bolts.
It's just a pain, and a lot of guys have found 12 millimeter, like 625 custom age type material gets most people to their goal of 1000 pretty reliably. And so, but if you're going beyond that, you want a little better clamp load up there. So OptiTorque has come out with these new stepped fasteners that are 14 millimeter on the bottom, 13 millimeter on the top, not 12 millimeter like stock.
Yeah.
They're a little bit bigger, a little bit fatter.
It's that custom age material.
But it's that good custom age, like ARP 625 type material. In fact, Opti Torque recently bought a steel mill. So they can tweak their material exactly how they want it because they own the
mill.
They own the mill.
Yeah.
Anyway, long story short, with these new fasteners, now you don't need to ream the head out because they fit through there, and you don't need to modify the rocker box. And so the stage 3s are going to have that optional hardware you can buy. I mean, and you can get regular other 14 millimeter hardware, but you know, there's some little things to address on the head,
Yeah.
reaming head stud holes and that. But that stage 3,
it's going to be really, really, that is what's in that truck. That's what's in my truck. I mean, we have ran those a lot. I mean, I'm at 1,500 horsepower on my truck. He's at 1,800 horsepower in his truck. So it's pretty potent. And so you guys, if you have a 5.9 common rail and you want to rebuild an engine, to me, man, I would go with a 6.7 crank, 6.7 block. That's what I did in my tow truck, and is so much better than the 5.9 ever dreamed of being. It's just so much better. The block is way more capable, can handle way more power. The big cubes make it spool turbos so much better.
I've broken quite a few 5.9 blocks, and looking at the power they're able to put through these 6.7 blocks, they are substantially stronger. That Siamese bore just really ties them together. And then honestly, if we get into kind of the science of blocks, the top of like a Cummins block is thick for about 700 thousandths, and then the cylinder walls get thin. Well, I'm breaking at that. These are thick for like 1.5 inches at the top.
The deck is thicker.
The deck's thicker, and so that's where all the power and pressure happens. So as the piston goes down, the pressure drops, the block is less likely to crack and fail. And so that's, the factory made these blocks better, and they are better. And so if you're building a hot street 5.9 common rail, or you want to do a hot P-pump 24 valve, man, it's really hard to look elsewhere than a good, you know, OEM 6.7 block.
The nice thing is, guys, on this stuff, it's all new. So you don't have to provide a core. We're just going to ship it to you. You don't have to send your stuff back to us. Worry about not getting a core charge. We're just going to send it to you. If you can sell your old stuff, great. More power to you. These are new parts, no core needed. So it's pretty awesome. Man, this has been a long parts bin. I hope you guys are still there. I hope you're still enjoying yourselves. So anyway, guys, if you need parts, stroker kits, 6.7 cranks, 6.7 blocks, you want to build an awesome motor, you want to build a big motor, I highly recommend it. It just makes driving so much more fun.
Should we tell them we might do a stage 4 at some point?
Yeah, maybe stage 4 at some point. So you never know.
We're playing with sleeves, deck plates, and fancy girdles. There's all kinds of stuff, but
that's coming.
But honestly, he's pushing that thing. I mean, he's up there at 1,800 now with
basically a stage 3.
With just a stage 3 block. So it's like there's not even a girdle on that thing.
Yeah.
We don't know how long it'll last, but that's why we test before we sell.
So anyway, guys, lots of cool stuff here. Call us to shop. We can get you a set up of stroker kits, cranks, blocks, all the stuff you need for your engine build. We'd love to help you make sure you get the right parts. So thanks for watching, and I hope you subscribe. And yeah,
see you next time on the Parts Bin.
See you next time.